Welcome to Study Loop.
Okay, we have an imine. I'm going to use pH for phenyl. And we are in the presence of water and hydronium ion. And I would point out that we know already that what we're dealing with is hydrolysis of our imine, generating an amine, in this case phenylamine, as well as a ketone, methylphenyl ketone, and we will regenerate our acid, which means the acid is being used here catalytically and is not consumed in the reaction. Okay, so we're going to use our elementary reaction steps when it comes to carbonyl and related structure reactions, which would be protonation, attack, deprotonation, and release. Okay, so the first elementary step is protonation of the imine to give an iminium ion. And the result of this is that the carbonyl becomes particularly electrophilic, at which point water will attack. And the double bond will swing up onto nitrogen as a lone pair. And this will now be OH2 plus, right? Because it was water, and now it's got a new bond. Oxygen with 3 bonds is always positively charged. This is where we show a proton transfer step. There's two ways to show this. One is to use water as an intermediary in which this proton transfers to water, and then the next step transfers to the nitrogen. But we're going to show this step as a direct transfer from the hydronium or oxonium ion onto nitrogen directly. Creating an ammonium ion, positively charged. Still have our phenyl, our methyl, and now simply a hydroxyl rather than a oxonium. At this point, the lone pair on the oxonium will push down to form what is the carbonyl bond, carbonyl oxygen, carbon oxygen double bond, where now our positively charged ammonium is a good leaving group, so that will leave. And we will then have separated our carbon nitrogen bond. So we're going to have sort of our side product ammonium now, our side product amine, phenylamine, and we'll have generated a carbonyl. It will be a protonated carbonyl, however. All right, we've still got that hydrogen there. Oxygen with 3 bonds should always have a positive charge, and our carbonyl carbon will still be attached to a phenyl, as well as a methyl. And the final step then is that water can come in, right? Remember, we had an extra water molecule hanging around that we've yet to invoke. That will come in and deprotonate our carbonyl, generating the neutral product. and our phenylamine, our methylphenyl ketone, and H3O+.